right, so the YouTube side is also streaming, so everything is being recorded now. And we got 4 minutes remaining. This is our last lecture, by the way. So it's a good opportunity to ask questions in today's lecture. And I put some of the resources for today's lecture in the pinned items of today's text chat. So this way you can get to both of the PDFs just by clicking on it. You don't have to look for those. And you cannot find those anyway because one is a one variation of exam 2. I want to bring it up because I want to kind of comment on what I expect when I ask people to explain something, and also to explain the grading scheme, just so that people can somewhat, self-assess, what they're gonna get as a grade for the second exam. It's difficult for me to prioritize and give point values to the second exam, so I'm still kind of working on that, um, putting down actual numbers, even though every single exam has been corrected already. It's just that the scoring part is not done yet. All right, so we got about 2 minutes and 20 seconds. All right. All right. Got another 2 minutes or so, or 1 minute and 40 seconds or so. And you probably have heard already, in fall 2020, all classes will be online except for very few classes, where the lab needs to be on the ground, and those may be on the ground. But by default, all classes are online in 2020. So, we have another interesting semester ahead of us. Very interesting. Yeah. So we got 1 minute remaining. And some of you can let me know, how many professors are conducting online classes or remote classes synchronous like this, and how many are conducting their classes asynchronous. Yeah, I just want to get an idea of what most people do, because personally I really like this format a lot better than asynchronous. So you can either direct message me, or you can reply to the class message area. Either way is fine. Okay, Carol says he prefers the synchronous method as well. I think the synchronous method gives us structure, which is, at least to me, it is important. Maybe to some people, they just want more flexibility and they don't need the structure.
I like it live also.
Oh, okay, thank you, Nick.
I know also I've been hearing that like what's it called? A lot of classes I've been having issues with cheating.
Ah,
Like in my engineering class, we didn't even have a final
mm-hmm.
because we couldn't tell who was cheating on the last two exams, so we just like ended the class.
Oh, well, that's not very comforting to know, because that means when people move on to a 4-year university, the 4-year university may notice some people may not be as ready as they seem to be. and then they will start to come back to us, come back to the community colleges and ask, how come these people are passing, your classes with a letter grade of, A or B or whatever, but they do not seem to understand the material, getting to our level. So that's definitely not a good sign, at least not to me.
Something that I was like just pondering as an idea that I thought was kind of interesting. It's like we're gonna be on online for this extended period of time, right? So
Yep.
almost a year.
Yep.
You know, what if, let's say hypothetically, society realizes that a lot of things can be done online, right? So maybe more classes than normal
Mm-hmm.
that being done online, and obviously people like have access to calling each other and things like that. Do you think that professors would like in do you think eventually the way tests would evolve to be more like group oriented and harder to make it more almost like real world?
Oh, I see what you mean. Because in real world, people work in teams, and as a team, they
Yeah,
have to solve problems together.
yeah, sounds.
Um, that is a very interesting question. It will work, and I think it is fair, but only if this group of people, will graduate together, and they guarantee that they will be working together. Do you see what I mean?
Yeah, that is true.
So yeah, because otherwise, some people can group with people who are basically above their own level. So in gaming, in League of Legends, this is called boosting, right? You play games with a lot of
Yeah.
people who are much better than that person really is. So that person can now have a much better win-lose ratio, and boost to the next grade. But that as soon as that person leaves that group and basically get randomly assigned to a different group, that person will not be able to perform at the level that people are led to believe, right?
Yeah,
So
something they
there's
should.
yeah, so there's that issue too. It's a very interesting time, because it's not like fully face-to-face classes. In those classes, people cannot cheat. I have heard a lot of horror stories, cheating stories, from, guess what, Berkeley. Okay, these are not from, oh, you mean, that CSU that we have never heard of. No, those CSUs actually have lower incidence of cheating because there are no reasons to cheat. At Berkeley, it is so competitive, and to a certain point that some people can call cutthroat. So that's how people can get ahead. That's how people can stay competitive. Um, and people work in rings, where one person who's really good with calculus will take the calculus exams for everybody else. Another person who's really good at, say, English writing will take the English writing classes for everybody else. So it's really not, to me, I would definitely not want to study in an environment like that. So
Yeah,
anyway, yeah, so it's
interesting.
an interesting question for, this time, because most classes are conducted online. All right, so I better get started with today's lecture because I do have quite a bit of material that I want to go over. Um, so what you see on the live stream is exam 2, and this is variation 46, which nobody gets in this class. Okay, so you might see some questions resembling what you have or is exactly what you have, but nobody gets exactly this particular combination in exam 2. So I want to go over this just a little bit because I want to let people know how I grade, how I'm prioritizing and assigning, numbers to answers. Okay, because this way people can kind of self-assess for themselves, what they're going to get for this exam. So for questions 1, 2, 3, and 4, they basically lump into the same category, which is basically me testing people. If I give you a relation, can you tell me what it is? Is it reflexive? Is it symmetric? And so on. Now, if it is true for one of these, you don't have to say anything. So let me just kind of work on one of these and show you what the different types of questions what the different kinds of answers I'm getting. Okay, so let's just say for reflexive in this case. Some people, okay, obviously, if there's no answer whatsoever, I'm not assuming if there's no answer saying true, I'm not gonna assume that it is reflexive. Okay, because people have to give me an answer, saying is it true or is it false? Okay. All right. So in this case, reflexive is false. Okay. So some people give me just an answer like that. Okay. Well, that is not going to get full credit. In fact, at best, okay, this kind of answer will get what is equivalent to a C, which is 1/2 of the points assigned to this kind of when I test for this. Okay, it will at best get only half the points because the question clearly states to use a specific example to show me why it is false. Okay, so now, some people may say needs, in this case, 4/4. Okay, so for reflect for being reflexive, I would consider this as a good answer. Okay, that's all I need. There's no need to explain, for every element in X, the pair with only that element in it, whatever that thing is, comma and itself needs to be in it. Okay, but for some of the other ones, that is actually necessary. So for reflexive, this is good enough. Okay, this would receive full points. For symmetric, in this case, it is not symmetric. Okay, so obviously, if there's nothing written about symmetric, that's a 0. If somebody gives me just false, that's probably a D in this case. Okay, and someone can say needs 7/3. Okay, without any explanation, that would still not get full credit. Okay, that might be a B in this case, but definitely not an A, not full credit. So it's a 75% of all the points, but not 100% of the points, because what I want is for someone to say um, something to the same effect as 3R7 is in here, but not 7R3. Okay, because that explains why it is not symmetric. Okay, if somebody just tells me that, oh, 7/3 is missing from here, okay, well, but why is 7/3 necessary to make it symmetric? Okay, so this last part here, which is the actual explanation, is important. Okay, asymmetric. Let's take a look at this one. Let's see. It is not asymmetric. Okay, it is false. Okay, so once again, okay, no answer is an F, which is 0% of all the points. Just saying false is a D in this case because it is not sufficient to get a quote-unquote passing grade for this kind of question. Now, if somebody says because 4/3 and 3/4 are both in it, that's a B. Okay, because the full explanation is 4R3 and 3R4, but 3 does not equal to 4. Okay, just saying that we have both 4R3 and 3R4 is insufficient because the reason why it is not antisymmetric is because 3 does not equal to 4. That is a crucial part of the explanation as well. So let's take a look at transitive. So in this case, it is definitely not transitive. Okay, and this is one of the transitive sounds pretty easy, but a lot of people actually miss the property of transitive because they forgot about this one. Okay, so this is false because 4R3 and 3R4, but not 4R4. Okay, because if it is transitive, then E being 4, F being 3, F being 3, and then G being 4, means that this should exist too. 4R4 should be true as well, but since it is not in the set, we don't have 4R4, and that is the reason why it is not transitive. Okay, comparable. Okay, so with comparable, everything has to relate to everything else. So once again, the lack of 4R4 is also can explain why it is so. Okay, so false because 4R4 is not there. Okay, because 4 does not relate to self. 4 does not relate to self. Now, with partial order and total order, I have seen some really terse answers like false. Okay, once again, that is not sufficient to get all the points. I'm not going to give people, with just false 0 points, but definitely not all the points. Because why is it false? Well, you have to go back to the definition of partial order. Okay, partial order requires reflexive, it requires antisymmetric, and it requires transitive, and all of those are false. So they're false because it is not reflexive. Now, if somebody just wants to save time and say, "Oh, since it's among other things, it is definitely not reflexive," that's already sufficient as an answer because in order to be partially ordered, it has to have all of those three properties. Just missing one is enough for this not to be partial order. And the same thing applies to total order because for something to be total order, it has to be partial order, and on top of that, it has to be comparable. So that means it can use exactly if partial order is false to begin with, that means total order can have a few different variations of fully acceptable answers. People can say, well, because it is not partial order. Okay, that's perfectly fine. Okay, because in order for something to be totally ordered, it has to be partially ordered first. Okay, or somebody can go back and say false because it is not reflexive. That would also be perfectly okay because being reflexive is a necessary condition of total order. So that's a full explanation to me at least. Okay, so 1, 2, 3, and 4, those four questions, I kind of lump them together, and I'm looking for consistency. In other words, I have seen some answers where that person seems to understand antisymmetric in one of the answers, and then with the other two, they're all wrong. Okay, so there's a lack of consistency of that person understanding and being able to apply the concept. So I will look at all four together to kind of determine the grade. Now, in questions 5, 6, and 7, yes, so 5, 6, 7 are kind of lumped together because all of these have the same format of I'm not telling you what R is, okay, but I'm telling you what I want in that R, and explain to me why it is not possible if it is not possible, and also give me an example if it is possible. Okay, so I lump all of these kind of together because people actually have to think about this and explain why it is not possible if it is not possible. Some of these questions actually have an answer that is possible, and some of these are not possible. In the explanation of things that are not possible, okay, some people may say, okay, these three things cannot happen together. Well, but if I can think of, a particular R where all of those things can happen together, then the answer is not going to get full credit because, it is not fully explaining why the combination is not possible because it's lacking one of the other ones. So the grading criteria for 5, 6, and 7 is a little bit different. Um, if people give me a particular R, okay, and I see that that R does not meet all the requirements that is stated here, then I will basically look to the one where the requirement is not met, and I will say, maybe this person does not fully understand what it means to be, say, not antisymmetric. Okay, so that's kind of how I'm grading, is going back uh, to see if I have evidence that a person understands the concepts and be able to apply the concepts. With the last four questions, from question 8 to question 11, those will be based on whether people can. There are a few things. Okay, one is whether that person understands what is a CNF, because after all the derivations of psi and also not phi, we should have CNFs. And most people do that. Most people are fine. They come up with some form of CNF. Okay, some may not be entirely correct, but nonetheless, it is a CNF. I think I've seen one or two answers where the answers are DNFs. Okay, they're disjunctive normal forms, so those would definitely be marked down quite significantly. Because they are not even targeting conjunctive normal form. And then I would also look at the derivation, and that's where I see a lot of really, really interesting stuff, okay, is the derivation does not make sense, okay? Um, it's not like it is wrong, okay? The derivation, gets to the correct format, but the application of the derivation is actually incorrect within the steps. So that is really kind of strange. Okay, um, and then some people, in when they derive not phi as a CNF, they just use a whole bunch of equal, but phi does not equal to not phi. So the introduction of the negation to the overall phi should not equal it should not follow the same chain. Okay, instead of saying phi equals to this, then it equals to this, then it equals to this, then it equals to it. Suddenly there's an overall negation. No, that does not apply. That overall negation is applies that is not phi. It is not phi itself. Okay. And then when it gets to the resolution, there was one answer, and I feel kind of really sorry because um, it was proven not using resolution in a single step. Okay, it was proven using some other means. I cannot give credit for this portion of the question because the question clearly states to use resolution and proof by contradiction to conclude. Okay, so it will be broken up into multiple parts, but I think the most important point is I'm not going to give each question its own points. I'm looking at questions 8, 9, 10, and 11 together to look for a pattern. Okay, does this person understand, how to derive? Okay, the application of the Morgan's law, distribution, and so on. Most people can get, the derivations right at least in a few steps. Okay, does this person, know that we want to end up with CNFs? Okay, once we have CNFs, does this person know how to apply resolution? Okay, and some people stopped the resolution too early. Okay, they make a conclusion of, oh, there are no further resolutions when there are actually further steps that can be performed. So that would also get, a little bit of point deduction. Okay, and then of course, it's the in the end, there is the conclusion. Okay, if there are no further resolutions possible and yet there's no contradiction, then we can use that and use proof by contradiction to say that phi is in fact a theorem. Okay, I'm reading Carol's comment here. What if your pattern is running out of time? So running out of time is so if you can get to at least one of these four questions and show me some steps, I will still be able to give partial credit of saying that, yep, I can see there's a pattern of this person knowing how to apply certain derivations. Okay. Yep. Okay. I'm just commenting on Carol's feedback here. Okay. All right. So, if it's consistent, steps, then they're not going to get repeatedly marked down, because I just have a category of stuff. But basically, the grading is going to be looking at, questions of the same kind and then look for patterns. Okay, look for evidence of understanding of the concepts and the ability to apply those concepts in problem solving. So that's why it's going to take me a little bit of time to determine, how to grade it, because I want to be able to tell you guys the quote unquote algorithm that I use for assigning the points. So this way, there's transparency, but at the same time, I also want it to be kind of fair and be able to adjust for the different situations. Uh-huh. Yeah, so if you cannot show me, resolution, then I cannot give points to resolution. So that's the whole deal. All right, so the importance of going back to exam 2 and go through all of this stuff here is because I want to give you guys plenty of, uh, you know, I shouldn't say warning, but I want to give you guys plenty of um, look ahead, okay? Plenty of look ahead to the final exams is, you want your answer to show your knowledge as well as your understanding, as well as, how you can apply the concepts to solve problems, okay? So don't be terse, okay? Because you'll be typing, okay? So don't be terse because I'm assuming all of you can type relatively fast because you're in CISP, programming. So don't be terse, just use explanations whenever you can, okay? And if you want to copy and paste from my notes, that's fine too, okay? You can just copy and paste a portion, into your answer, okay? That's perfectly okay as well. But try your best to show me that you know the concepts and you also know how to apply the concepts, okay? Because that is really what I want to test in the final exam and also in all of my other exams. Um, okay, so in the final exam, I am going to make sure there are no duplicate questions. That is definitely a flaw in the algorithm that I use to generate these question combinations. Um, and I have a pretty good idea where the bug is. Okay, I just didn't have time to double check everything. Um, so so there should not be duplicate questions in the final exam. All right. So now we are moving on to the practice exam from last year. Brenda has a question. For exam 2, we will be graded out of 11 questions or less on Canvas. It's not going to be based on the number of questions, as I mentioned a little bit earlier. So I will look at questions 1, 2, 3, and 4 together, and then the line items, is going to be, um, you know, reflexive. Does the answer from question 1 all the way through 4 show me that, to what level does the answer show, full understanding of whether a relation is reflexive or not. Now, if a person gives me the correct answer for questions 1 and 2, and not have enough time to show any answer for question 3 and 4, obviously that would get a lower grade compared to someone who shows me all 4 being correct. But it would still be sufficient enough for me to kind of say, well, I'll give it a B because that person has shown enough consistency across question 1 and 2 to show me that reflexive is fully understood. So I think somebody has a question. Nick has a question. Go ahead.
Yeah, just one. Do you know, has that, like, off the top of your head, did anybody finish the entire test?
Yes, a few people did finish the entire thing. um Not that all the answers are fully correct. I think there were some minor mistakes somewhere, so it's going to be rescaled to reflect that the test is a little bit long. So people do not, so when you look at the entire exam, I will make it so that people do not need to fully understand, fully answer, okay, not fully understand, but fully answer all 11 questions all perfectly to get an A.
Okay.
So in the end, I'm going to make sure that the ABCDF proportions, would remain about the same as the quote unquote average of me teaching this class, because I have all the statistics, so I know how the proportions should be.
All right. That sounds.
So that applies to the final exam as well, okay? Which is not to say that if the entire class, do really, really well, the lowest score is 90% and the best score is 100%, that I will still artificially break it down to A, B, C, D, F. That is not what I'm saying, okay? If the entire class, get like 90+% in the final exam, the whole class can get an A for just the final exam. So I don't have a problem with everybody excelling in the class. It's just that when the scores are kind of leaning on the low side, then I would have to make some adjustments to maintain the proportions. All right, so Brenda has a question. Do I think we all have enough time on the final exam? No, there won't be 11 questions. The final exam is going to be a little bit different compared to exam 2 just because of the subject matter. So, um, the subject matter of the second exam is mostly relations and also resolution. And with relations, I was kind of guessing that it doesn't take as much time to answer one of these questions, to figure out, all the properties of a relation. So I put, a bunch of those, like questions 1, 2, 3, and 4, all having the same nature, just so that I can see if there's a consistency across all the answers, to make sure that, okay, it's not just someone guessing the answer correctly, it's consistent. But with the final exam is mostly going to be on Dijkstra's algorithm and the A star algorithm, and those are not going to be short questions. It's not going to take a short amount of time to answer those questions. So as a result, I cannot give you guys, like a whole bunch of questions. It'll be relatively few questions, and then I have to break each question down to smaller steps or stages so that people can get partial credit even if they don't have enough time to answer the entire thing. And then Sersha, I hope I pronounced the name correctly, asks, will there be any questions from the probabilities section? Oh, I totally forgot about the probability section. Um, hmm. The answer is yes. I'm gonna ask some questions about the probability section. Yes, totally forgot about that. Because the way I ask questions in this semester is a little bit different. Normally, I ask probability questions in the second exam, but this semester I did not do that. And then Krishna has a question. Should we expect questions from counting principles, discrete probability? Okay, so big O, little o, omega, big theta, and so on. Those are I will say that I'm not going to ask questions about those, okay, so in terms of time complexity, because the time complexity stuff is good to know, okay, good to know what is big O, what is little o, what is big omega, what is little omega, and so on. But in terms of asking questions about those, I do not feel comfortable doing that because we did not do any homework, graded or otherwise, on those concepts. So I'm not going to ask questions about the time complexity topics. With counting, I will ask questions because we did work on one um, programming assignment on that one. And then with predicate calculus, this is what I was talking about on Monday, was to give you guys an assignment like thing so that you can actually work on it, for days, and then I'll give you a due date so that you guys can turn in the solution. Um, so it's not going to be in real time because I don't want you guys to have to work on a predicate calculus program in real time to try to get it to work, because I understand that sometimes if you miss one little thing, okay, the program does not work. But how long it takes to catch that one little thing that makes your entire program not work, that is unpredictable. So that's why I would probably give you a predicate calculus uh, assessment work to do, which counts as a part of the final exam, but it's not going to be real time during the final exam time. All right. So I hope that addresses most of the issues. And Carol has something. When when will it be due? Um, I can push it all the way to the last day of the finals week, okay, which I think is Wednesday, right? Yeah. So I can push it all the way to the end of next Wednesday for just that piece, okay? But the exam for the final exam itself is still going to happen on Monday during the time. No, no, not noon. It's going to be following the final exam schedule for the college. So I think we worked it out earlier or on Monday, but I cannot remember. So let's look it up again. ARC final exam schedule. Uh, okay, we'll get to the review portion. I just want to confirm the time first. And I'll send an announcement to the whole class too, because some people apparently do not even know that we have a Discord presence for this class. Okay, so this is a Monday, Wednesday class, and the start time is noon. So that means our actual exam time is going to be 12:45 to 2:45 p.m. on Monday. Yep, there we go. So that's that. All right, so let's go ahead and start to do some review of the questions. And Peter is typing, so I'm gonna switch the screen and wait for Peter's question. All right, so Peter is asking, are those time limits required by the syllabus, or can we have more time because it is online? Hmm, I think I'm going to try to stick with the 2 hours because um, there are other classes, where they also follow the same final exam schedule. So if I push my time back, someone may not have enough time for the next exam. So I cannot allow more time. Yeah, so Carol has a final exam for CISP 430, which is at 3 o'clock according to the final exam schedule. So I cannot extend the final exam time. But it's okay because it applies to the whole class, so it's not only applied to a few people. So nobody's going to get extra time unless they have DSPS paperwork. Then those people can get extra time. All right, so moving on to the um, a sample of the final exams from last semester. So some of this stuff here, will also get changed. This is from uh, last year, okay, the final exam of last year. So the portions that will be modified or it won't apply anymore is obviously additional sheets of paper doesn't apply anymore, okay, because you're gonna use the same approach as the second exam, where I will give you Google Documents or Google Spreadsheets depending on the type of question to work on. So you're not going to turn in, photocopies of on sheets of paper. So that's not going to be an issue anymore. There's no need to write down your name because I know which file has been assigned to which student, so it's all going to be okay. Just make sure that you do not write the answer of one question to the document that belongs to another question because I might break it up into multiple documents. Write legibly also does not apply, or hopefully does not apply. I hope you guys will be typing, okay, and not doing everything by handwriting. So go ahead and just type as much as possible. And then the resources available to you would also be changed. Okay, so in terms of what resources you have during the test. Um, okay, so do not discuss the questions with students who may not have taken the exam. That still applies. This is an individual assessment. That still applies. Despite Nick and I were talking about, maybe team-based assessment would make sense at some point, but for this exam, it is still individual. Um, Sharing of material during the exam is not allowed, okay, but it is online, okay, so everything is online. You can read the notes if you want to online. You can watch YouTube, online, during the test. You can do everything online except for one thing, okay, except for live communication with another person, online or otherwise, okay. So as long as there's no collaboration or communication with somebody else, maybe with me, okay, if somebody needs a clarification of a question, that person can communicate with me, okay, but no, not anyone else, okay. So as long as it is not a communication with anybody else, you can go to Wikipedia, you can go to Stack Overflow, you can go to any place you want to find resources to help you answer the questions. All right. So moving on. Okay. So it's going to be a change. Okay, because this is the first time that I have to deal with an exam like this. So question 1 of 5 is uh, giving you x as a set of destination vertices, and then the graph is, has the vertices in V, it has all the edges in E, and the first part is to just to draw the graph itself. Okay, that should be relatively easy. Okay, just kind of graphically represent it. Part two is to come up with a distance function d and label the edges of part one with the distances. The criteria is L of A should be updated as many times as possible. So you can see how, the first part of the question, let me highlight which part here. So you can see the first part of the question does not give you the distance functions. Okay, the distance function is not presented here because I want you to come up with the distance of all the edges. So to maximize the number of times that L of A is updated using Dijkstra's algorithm. Okay, and then part three is trace the algorithm in the given sheet. Okay, and I can show you what the given sheet looks like. So this is the given sheet, which means, for our final exam, I can actually just pre-make the spreadsheet for you, and then you have just, each person has that person's own spreadsheet to work on. Okay, but it's going to be pre-formatted in a certain way so that you don't have to waste your time to format it. Okay, so part three is really a verification of the second part. In other words, part three here is really here so that you can follow Dijkstra's algorithm, and by going through that process, you might find that, oh, okay, what I thought, this setup will at least revisit vertex A at least once, did not even revisit it once. Okay, it was visited only once, and it was done. Okay, so step three, in this particular question is really a verification step, so that you can double check your answer to the second part. And if it doesn't work out the way it's supposed to, part three will tell you that it's not working, and then hopefully you have time to go back and adjust the distance functions and then rework the algorithm. So that's question number 1 of 5. Question 2 of 5 is a predicate calculus thing. It's a prolog kind of thing. So in the prolog program, you're given the following ground rules. Okay, so ground rule, which is also known as a fact in the prolog program, is a rule that only uses atom on the left-hand side. So in our example, okay, parent of in open parentheses, Homer, comma, Bart, close parenthesis, and the period, that is a ground rule. Okay, it is a fact. Okay. So the format of the ground rules, it would be these four. The first one, parent of, would do the same thing as what we have already talked about on Monday. It expresses whether a particular atom is the parent of another atom. Okay. The second and the third one are fairly clear what they are. It's basically identifying the gender of a particular atom. In the whole program. And then the last one is the age of a particular atom. Okay, so we have age, we got gender, and then we got the parenthood relationships. Okay. So you're also given the following rules. Okay, you're given the rules for determining cousins. Okay, so we have so cousin is interesting in this case because it's not just the usual quote-unquote cousin. This also handles first cousin, second cousin, and so on. Okay, so so let's check out the cousins first, because I want to use this opportunity to also kind of further explain predicate calculus. So let's look at the first rule, which is cousin xy0, which is the base case of quote-unquote the recursive definition of cousins. So in this case, x1 is a variable that only appears on the right-hand side, which means it is an existential variable. So we need to come up with an x1 such that x1 is parent of x and x1 is parent of y, and then the backslash plus is saying, but it is not the case that x equals y. Okay, so this is what we call zeroth cousin, otherwise known as, okay, I'll let you guys try to think about this. Okay, there's a very common term for this definition of zeroth cousin. What is it? X and Y are different, but they share the same parent. What do we call these?
Sibling?
Yes, woohoo! Yes, siblings. So siblings is a special case of a cousin. Okay, because first cousin is the actual first instance of what we consider cousins, but zeroth cousin in this case is just sibling. Okay, they share the same parent. Okay, so now what about nth cousin? Okay, so this is generalized to nth cousin. So with nth cousin, it is defined as this. Okay, um, x1 is the parent of x, y1 is the parent of y, and then we establish that n1 is n minus 1. Okay, in other words, we figure out what n is, and then we say, okay, n minus 1 is n1. Okay, so the last rule that we need here is x1 and y1, they should be n1 cousins. Okay, so does everybody kind of understand this? Yes? No? Maybe? Okay, so I think I sense hesitation. So what I would do is, and I thought I had it somewhere. Oh, I still got it here. There we go. All right, so this is good. Haha, I like that. Okay, so I'm gonna put this over here. Okay, so this is the Simpsons family tree. Okay, so we want to look at let's see, we only got first cousins here. Okay, so we only got first cousins here, but we want to see how the rules apply. Okay, so we want to look for first cousins, and first cousin means the parents of the two people that we are concerned about, they need to be zeroth cousins. Okay, so we can see, we can check out between Maggie and Ling. Okay, so one of Maggie's parent is Marge, one of Ling's parent is Selma. So now the question is, does Marge and Selma relate as zeroth cousin? And the answer is yes, they do, because they both share a parent, which is either Jacqueline or Clancy. So that makes Maggie and Ling first cousins. Okay, does that make sense? Are there any questions about how this picture is used as an example to illustrate how the second rule, which is cousins x, y, and how that works? All right. All right. So I'm assuming it's all good. Okay. So the question is about, okay. So to continue to read the question, I'm at this point here. In some cultures, cousins have specific names if certain conditions are met. So in Chinese culture, okay, there's a term called baojie. Okay, I'm probably pronouncing it wrong. So for those of you who have studied Mandarin, you can correct me. So baojie is someone who is a daughter of a sibling of the said person's mom who is older than the said person. Okay, so um, it it does apply in the example, in our case. So we just have to kind of okay. Let me pull the example back up here. Okay. All right. So in this example, it is not clear about the gender of Ling. Okay, so we're well, looks like she has a bow on her head, so she looks kind of female. But anyway, let's see if Maggie is a Belgian of Ling. Okay, and when we look at the requirements are, okay, so getting back to the rules here. So the requirement is, first of all, one has to be a daughter of a sibling of the mom of the other person. So in this case, if the Belgian is Maggie and the said person is Ling, let's see if all the rules apply. So we want to check out whether Maggie's parent, Marge, okay, mom, is a sibling, or okay, I take it back. Let's see if one of Maggie's parent is a sibling of Ling's mom, and that seems to make sense, right? Because Selma is female and she is parent of Ling, so that makes Selma mom of Ling. And Marge relate to Selma because they are siblings. So Maggie's parent, Marge, is indeed a sibling of Ling's mom. Okay, so that meets the first requirement. But what this picture does not show, and I do not know whether it is true or not in the Simpson universe, is Maggie is older than Ling. Because it only works if Maggie is older than Ling, that Maggie is Ling's Belgian. Okay, so those are the rules, to qualify as Belgian. And the question is asking, okay, define a general rule is Belgian, so that to determine whether X is a Belgian of Y. Okay, so that means for the second part here, it would be kind of predicate calculus logic here in prologue. All right, so do we have any questions about this question? No questions. All right. So in this case, the expression has to do with, first of all, there's an expression of mom, okay? There's the expression of sibling of mom, and then there's the expression of daughter of the sibling of mom, and then there's the expression of whether that person who is the daughter of a sibling of mom is older than the person. So all of those requirements have to be met in order to call somebody Belgian. All right. So we can work on this one a little bit later. Okay. I don't mind spending some extra time, maybe either later today or tomorrow, to explain the solution to this particular question. But for today, it is kind of important to keep moving forward so that we at least have a sense of what questions were asked last year. So question number 3 is one of the questions that I will not ask in this final. So I'll read it first. Okay, it doesn't, it's just because I don't ask this question the same way that I would ask in last year doesn't mean it is not important. Okay, because it is still important that you kind of think about this and understand the concepts involved to answer this question. So the question asks like this: based on algorithm 1, which is the Dijkstra's algorithm, tech has a conjecture. A conjecture is basically just a proposed statement. Okay, tech has a suspicion that something is true. Okay, and that basically says, given any graph G, in all iterations of the while loop, okay, every r in V, for every r in V, if L of r is less than infinity, that means P of r. Now P of r is true. Okay, it explains what is P here. P of r is true if and only if there is a path from vertex r to one of the vertices in the destination vertex. Okay, so that's a conjecture. Okay, it doesn't mean it's true. It doesn't mean it is given to be true. It is a suspicion that this is true. So the job of students from last year is to do one of the two. So either prove me wrong using a counter example. So how do you use a counter example? Is to come up with a particular example where a particular vertex will get an L value that is not infinity, and a path does not exist from R to a destination vertex. Okay, following the Dijkstra's algorithm, somehow that scenario happens. So that's proving a conjecture is wrong using a counter example. Or failing that, prove that I am right. But this time you have to use a proof by induction approach. So now this is kind of going like, well, how do those two concepts relate? Okay, proof by induction is a concept that we used earlier to prove certain things, but this doesn't seem to relate. So tech can only be right or wrong. So pick one of these two and try to go for that approach. Do not use the interpretation of R as a part of the proof. In other words, R is supposed to be the length of the shortest path from a vertex to a destination vertex, but you do not want to use that interpretation, because otherwise it becomes the reasoning becomes circular. So you cannot use the interpretation. You can only use how L is updated in the algorithm as a part of your argument in your answer. Okay. So now the next question is, what induction are we talking about? Because induction means, there has to be a base case, okay, k equals to 0, right? And we have to say when k equals to this number, we assume the theorem is still true. Now we prove that for the next number it is also true. So in this case, L of I, okay, L subscript I refers to function L, or the definition of function L for iteration I. Okay, the first iteration, you can call it iteration 1 or iteration 0. It doesn't really matter whether you start with 0 or 1. Okay, the next iteration is 1 plus that, the next iteration is 1 plus that, and so on. So the question now is, can we prove one way or another? Is tag wrong? If so, can we come up with a counterexample? Is tag right? In which case, can we prove by induction? Okay. Now, since I'm not going to ask the same question again in the final exam, in fact, I usually do not ask the same question ever. Okay. But I think it's important to understand how to solve this particular problem. Okay. Does anyone want to volunteer and get it started? Because it's proof by induction, which means we have to start with a base case. So what base case are we talking about? All right. So Carol says, so I don't think there's a counterexample to prove me wrong. Okay. Lengths are initialized to infinity until they're explored. Very good. Okay. So Carol is already using reasoning based on the algorithm itself to basically say, no, we probably cannot find a counterexample. Okay. Now, that by itself is not a full answer for this question, but it is a good start. Okay, because what that means is Carol is looking at the algorithm itself and try to use the algorithm to reason out, why we cannot find a counterexample. Because now when you look at the algorithm here, we look at how L of V is updated. Okay, so the only L of V that is initialized to something that is not infinity, which is 0, is the destination vertices, right? So can we argue that a destination vertex does not have a path to a destination vertex? Does that make sense? No, that doesn't make sense at all, right? Because a destination vertex is the destination already. So a path, even though it is a null path, which means it has a 0 length, that path exists. You're already there. Okay. Okay, so what about all of the other vertices that are not destination vertices to begin with? They all got initialized to infinity. The L value of vertices that are not destinations, they're all initialized to infinity. Okay, so now the question is, well, what turns something from infinity to non-infinity? Because that really is the key to say, can we come up with a counterexample? So we look through the algorithm. Okay, we don't even bother with the rest of the logic. We start with this. Okay, and we say, well, this is the only update. Okay, this is the only part that we update the L value of a vertex. How do we get here? Okay, so that becomes the big question, is how do we get here? Okay, and can t be infinity in this case? Okay, or does t have to be less than infinity? So what we do is we now execute the algorithm backwards. Okay, so that means we have to get to here first, right? Because if this condition is false, we are not going to get to line 18. So we have to look at the condition of line 15 to say, well, to get to line 18, line 15 has to be true. So if line 15 is true, that means t is not infinity, because if t is also infinity, we cannot compare two infinities. Okay, it is undefined whether one infinity is less than another infinity. So that means t has to be non-infinity. All right. So if t is non-infinity and t gets its value from here, what does that mean? Well, that means L of v is also not infinity, okay? And it also means that wv is not infinity. At least it exists, okay? So the fact that dwv exists means there is an edge going from vertex w to vertex v, okay? Um, and so now the question is now hinging on what about v here, okay? How do we know v uh, is a vertex that has a path to a destination vertex, okay? So that becomes the next question, right? Well, that is where induction comes in handy, because v is the result, okay? We can rely on this as the result of the previous iteration of this while loop. That is the fact. So we make use of the induction assumption that by iteration k, that any vertex that has an L value that is not infinity has a path to a destination vertex. That is the induction assumption for iteration k. So in iteration k plus 1, then we make use of that induction assumption and to apply it to L of w. In other words, by the time we get to iteration k plus 1, where we have to determine, when we update L of w, L of v is already non-infinity from iteration k, the previous iteration, and then by induction assumption, we already know that v, there's a path from v to a destination vertex. Okay, sure, I can do that to go over proof by induction. So the induction step is easy. Okay, so now the question is, what is our base case? The base case is iteration 0, which is before we get into the first iteration here, which means the first time we get to line 10 after initialization, is the theorem right already at that point? In other words, when we go from line 9 to line 10 the first time, okay, can we say the theorem is already true for iteration 0? Okay, well, let's think about it. Okay, at that time we have done all the initialization from line 1 to line 8, but we have already said that the only vertices that have a non-zero L value at that point are the destination vertices themselves, and they have a path to a destination because they are the destinations. All of the other vertices have a L value of infinity. So, well, I mean, there may be a path from these vertices to a destination, but it doesn't matter because if they have a value of infinity, we are not even going to question whether there's a path from those vertices to a destination vertex. So the base case of the induction is true to begin with. In iteration 0, the theorem holds true already. So that's the kind of reasoning that I want to use, to prove the theorem. Now, do you want to use for all there exist the mathematical symbols and or and whatnot? No. Okay, so the expectation for this particular question was really just to go through the program and reason out and explain to me, how the pieces connect. So to answer Carol's question, which is what is proved by induction? Okay. So proof by induction has 3 key elements. Okay, so let me do this. Okay, so proof by induction has 3 pieces. The first piece, okay, switch back to a pencil. So the first piece of proof by induction is the base case. Okay, the base case usually says for k equals to 0 or 1 or some exact constant value, show that the theorem is true. Okay, that's the base case. The second step is to have an induction assumption. So this is the induction assumption. So the induction assumption says, assume the theorem is true for case k equals to n. Okay, and then the third step is the most difficult part. Okay, which is to make use of the induction assumption to prove the theorem is true for case k equals to n plus 1. So that is the format or the framework of proof by induction. You have a base case, which is typically fairly trivial to prove, okay? And then you have a induction assumption, which is the magical element of proof by induction, is to say, let's magically assume that the theorem is true for k equal to n, okay? Equals to n. And then the next step is the kind of the most difficult step, is to say, well, based on that assumption, can we prove that the theorem is true for k equals to n plus 1? So that is the framework of proof by induction. All right. So now we are not going to ask the same question in your exam, so there won't be a proof question like this in your exam, but I still think it's important to understand, how to prove, in how to perform the proof in in question 3 or 5, because that requires people to understand the algorithm itself and be able to reason based on the algorithm itself. Okay, and that's something that I definitely want to test on, is whether people understand the algorithm or not. Okay, question 4 is going back to algorithm 1 again, which is Dijkstra's algorithm, and this time TAC has another conjecture. So the conjecture is no edge in E would get explored on line 13 twice in the execution of the algorithm for any graph. So once again, you can either prove me wrong using a counter example, or you can prove me right, but this time use proof by contradiction. So, and Krishna is typing something. Let me wait a little bit here. All right, so the question is, can we explain the proof by contradiction? Oh, we may not have time to do that. So let me see if there's enough time. If I don't have time to do it, I can explain it when I do have time, because I have a union thing and also a curriculum thing to do after this class. Yeah, everything got kind of you know piled up at the end of the semester. This is the last day of instruction, and then I have tons of stuff to do in addition to instruction. But I will find time to do it, as long as somebody kind of nudge me and remind me to do it. Okay. All right. Thank you. So getting back to question number 4. Okay. So let's go back to line 13, of the algorithm, and see why the same edge cannot be explored twice in the algorithm. Or is it even possible? Okay. If it's possible, then you have to show me that I am wrong in that assumption. And then hint 32, please use your name in the class, because uh, I think I have a good idea of who you are, but still. Are both of these tests in the share folder? They are not in the share folder. It is in today's pinned messages. Yeah, just give us a hint. 32-bit. Okay, so let's go to line 13 here. So line 13 is right here. it says for each W, V in E, do blah blah blah. Okay, all right. So the question is, well, can we re-explore the same edge twice in Dijkstra's algorithm? All right. So what do you guys think? And this time we want a proof by contradiction, which is a different thing. So proof by contradiction means that we have to negate the theorem first and then show that the negated theorem leads to something that is contradictory with what is given to us as facts. Okay, so, well, what do you think? Let's assume that it is the theorem is correct. Okay, so let's say the theorem is correct and then we use proof by contradiction. So proof by contradiction says let's negate the theorem. Okay, when we negate the theorem, that means we are re-exploring the edge twice. Okay, there's at least one edge in the graph that got explored twice on line 13. Okay, so that means the edge would be re-explored in 2 iterations, or we choose the vertex v from Q in 2 iterations of the while loop. Okay, so why is that not possible in Dijkstra's algorithm? All right, so since there's an absence of discussion, I'm going to show a graph here. Okay, so this is one of the destinations. Okay, it doesn't really matter in this case. And here is an edge. Okay, this is an edge. This is vertex v. This is vertex w. The edge goes in this direction, and and there's a path somewhere to x, down the line over here. So the question is, can we re-explore this edge more than once? Okay, in other words, when we go back to the algorithm, oh, okay, sorry, the algorithm is in the same document, just a little bit earlier. Okay, so when we go back to the algorithm on line 13 here, why is that not possible? Okay, so what we need to do is to find out, okay, I keep switching to a different screen, but it's actually in the same screen, the same document, just a little bit further down here. There we go. Okay, so the first time we explore this edge, okay, so the first time we explore this edge, 2 things can happen to W. Hero types, well, the length gets updated the first time we explore it. Yes, that is correct. So the first time we explore this edge, there are 2 things we can do to W. Either W got a new L value, or W does not get a new L value, right? Okay, the very first time W definitely gets a new L value, but L of W can get updated multiple times. Okay, we know that one already. So the question is, can the same edge get explored twice? Which basically is asking, can vertex V get put back into Q more than once? Okay, so let's just say that vertex V can be put back into Q more than once, then L of W can get updated again, so the edge can be re-explored. Okay, so that means, well, that sounds kind of plausible. Okay, so we want to construct a case where that happens. So this is the destination, so we want to construct an example as simple as possible. Okay, now this also relates back to the earlier question, in question number 1, where we want to maximize the update of L of something, L of A, as many times as possible, right? So that's important because so now we want to construct a case where there's a vertex A, okay, that goes to X using multiple different paths. Okay, so we would need at least 2 different ways so that it gets updated more than once. Okay, so one is a straight edge, just one single edge. The other one goes through a different edge B, and a different vertex, so it's broken up into two legs. Okay. And then the straight edge is going to be the one that has a higher, a bigger distance. So it's going to have a bigger distance, and okay. So let's say this is 3, and this is a 1, and this is a 1. Okay. So when we start with the destination vertex, okay, it would put both A and B into Q. Okay, so A is going to be into Q, and at that point L of A is 3. It would also put B into Q. In that case, L of B is going to be 1. Okay, but the algorithm is not going to choose A to expand first. It's going to choose B because B looks more promising because its L value is smaller. So when B is expanded, then we'll update L of A. So L of A gets updated to 2, but it is not put back into the set Q after it is removed. Okay, so no matter what you do, okay, you will find that we do not expand a vertex. We do not choose a vertex from Q until we have already figured out the shortest path from that vertex to a destination vertex. Is that okay? So in Carol's question, so what if the lengths are the same? Okay, so let's say they are the same. Okay, so even if the lengths are the same, it will still prioritize the expansion of B because L of B is less than L of A. Whoever has the least L value within the queue is the one that gets picked. Is that okay? Does that explain, to Carol? Okay. All right. Cool. So now we want to come up with the argument is now to basically say, so I hope you guys are following the reasoning, because the reasoning says, okay, an edge can only be re-explored if we have a vertex that got removed from Q more than once. Okay, the first time it got removed from Q, we explore all of its incoming edges. If it somehow got put back into Q, okay, and it got removed from Q again, then those incoming edges will be re-explored again. So that's the only time this can happen. So now we are looking for cases or reasoning whether a vertex can be removed from Q and yet be put back into Q at a later point in time. Okay, so now we go back to the algorithm. Okay, because when we go back to the algorithm, we find the logic that we need, or the pieces of logic that we need, is how do we choose something from Q to remove from Q? Okay, that's the job of line 11. So we are looking for something that has the least L value in Q and remove that one from Q. And the L value is representing the length of a path known at this point to be the shortest to a particular to a destination in the graph. So to have that vertex to put back into Q means that at some other point we discover that a vertex that V is going to has a shorter path, and that's how we put V itself back into Q. So that is not possible. That is not possible because of the way we perform this comparison, because nothing is going to get updated unless unless a shorter path is discovered. So in order for a vertex to be put back into Q, in order for line 16 to happen, we must have found a shorter path already. So if a particular vertex has a shorter path, it means one of its immediate downstream vertex also has got a shorter path in order to put that vertex back into Q. But if that is the case, we should have chosen the vertex with the shorter path already when we perform this step. So V should never have been chosen to begin with. Um, I guess the explanation is not quite as clear as I want it to be. So let me see if I can reformulate this at a later point in time. Okay, but I think the key elements are there. It's just that I'm not connecting the concepts in a very clear way. But because we are running out of time for today's lecture and I got stuff to do after the lecture, I'm just going to move on and continue on to question number 5, just so that we have the exposure of every single question. So question number 5 is going back to predicate calculus, and this one is kind of interesting. It's basically saying that let's say there are 9 people defined, okay, using the parent of rules, okay. What is the maximum number of answers to the query of cousins, of basically second cousins, okay? If you can have 9 people, okay, and you express the parent relationship of the 9 people, how do you organize the parenthood of these 9 people so that you have the most number of second cousins? Okay, that's it. Okay, that's basically what the question is asking. The last part is a guidance of how to present your answer. How would you arrange the parent of clauses to maximize the number of answers to cousins xy2? You can answer this part using a graph where a particular edge going from A to B means A is a parent of B. You can also you can assume you can use simple atom names like A, B, C, D, and so on. So this way you don't have to actually come up with names, for this answer. Okay, so let's go ahead and answer this question. Okay. All right. So to answer this question, okay, we are looking at second cousins. All right. So Carol types here to make as many parent relations as possible, splitting the total number in half, the first to the second. Okay. All right. So second cousin means how many levels do we need in this tree? Okay. So let's check this out. So we got A and we got B. Okay. So if we have a C, if we have a B over, if we have a C over here, that's 0th cousin. Okay. So that doesn't work. And if we have another person down here, that would be first cousin. So we need this many levels of in order to have a second cousin, right? Does it make sense, Carol? Okay. Okay. So we also know that this is E, this is F, and this is G. So A and G are second cousins. Oh, okay, I see. Okay, no problem. So we know A and G are second cousins. So now the question is, I have just used up 7 of the 9 allowable people in this graph. So A is a second cousin of G. If I put a B here, B is also going to be a second cousin of G. Okay? So now I have used up 8 people. 1, 2, 3. Oops, cannot use B over here. So G, H. Okay, this is H over here. So we have 1, 2, 3, 4, 5, 6, 7, 8 people. So I can use one more. So now the question is, where do I put that one more person in order to maximize the number of second cousins? Okay, or people who can claim each other as second cousins. So we got off of F. Okay, so let's examine that. Okay, so if I put one over here, G H I. Okay, so I goes here. All right, so let's look at this. Okay, if we look at this, A, so the second cousin relationship would be A I, right? A G, and then H I and hg. So we end up with 4 second cousins. Okay. On the other hand, if we put I, as a descendant of B, then we only end up with 3 second cousins. Exactly. So Carol is right. Okay. If we hang I of B, okay, so I'm using a dotted line here to basically say let's propose it here, then we end up with only 3 second cousin relationships, because A, H, and I in this case, they're siblings, they're not second cousins, but each one of these 3 would be a second cousin to G, but that means we only got you know not counting the symmetric relationship, we only got 3 distinct second cousins. Okay. Now, but the flip side, is true in either case, because you can say I is a second cousin of A, G is a second cousin of A, I is a second cousin of H, and G is a second cousin of H. So this works out better compared to the other one, because if I choose to do it the other way, okay, I'm going to use light green to represent what I mean by that. Okay. Then we have A, G, H, G, and then we have IG, and even counting the symmetric relationship thing, we still only have 6 second cousins and not 8 in the other case. So the using the black line and not the green line is the proper way to arrange the 9 people, so that we end up with the most number of second cousins. So that answers the 5th question. And we are out of time. So
I do have a question about that answer real quick.
yeah, go ahead.
You're counting the relationship from A to I as being separate from I to A?
Well, they're symmetric, because if A is a second cousin of I, then I is also a second cousin of A. So Prolog will find both. In other words, if I write a Prolog program, okay, let me scroll up. Okay. So if I write a Prolog program using exactly those rules, and I ask, okay, show me all the second cousins, which basically the question presented is going to be cousins uppercase X, uppercase Y, and a 2, and then press the enter key. It will give me symmetric relations. In other words, in the graph that we have in here, it will give us A, I, A, G, H, I, H, G, and it will also give me I, A, G, A, I, H, G, H. Because being a second cousin is a symmetric relationship. If someone is a second relation, if A is a second cousin of B, then B is also a second cousin of A. Does that make sense?
Yeah, it's just, I guess I'm looking at the relationship itself, not the
Mm-hmm.
perception of
Oh,
who's
okay.
related to who.
Right. Now, second cousin is, I mean, if you use just cousins, it's always symmetric. Okay, first cousin, second cousin, third cousin, they're all symmetric. But when you look at removed, I'm not sure, whether the definition, says it is actually symmetric or not, because removed means they're not of the same generation. They're off by a certain number of generations. So I'm not sure whether in that case, can you say, A is a second cousin of B1 removed? Okay, is that saying the same thing as B is a second cousin of A1 removed? I'm not a native speaker, so I'm not really sure about the use of that term, second cousin one removed, whether it is indicating the first one is 1 generation older than the second one or not. So I cannot say to that. But the other question that we have, the Bell-Jet type of relationship, is definitely just one way, because one person has to be older than the other one to qualify as Bell-Jet. So that one is definitely does not have the symmetric property that we see here. But regardless of whether it's symmetric or not, because it's going to be symmetric either way. So whether we hang the node I under B or we hang it under F, whether it's symmetric or not doesn't matter, because all we are doing is doubling the number of second cousin relations. But either in either case, if we have to choose whether I is a descendant, whether I is a child of B or whether I is a child of F, you know, for that decision, it doesn't matter whether the relation is reflexive or is symmetric or not. Does that kind of help answer the question?
Yeah, I suppose. Thank you.
Okay, excellent. Cool. Um, so I think we are gonna conclude today's lecture unless there are some pressing questions. And then I'll reformulate my answer to question number 4 and try to present it in a way that makes more sense. Basically, when I say makes more sense, means the points are more logically connected. So one point leads to another point, leads to another point, whereas my presentation today during the lecture is a little bit more scattered. All the things are there already. They're just not presented in a way that things are linearly connected. So I will reformulate the answer to accomplish that. But we are not going to have proof questions like this kind in our final exam. Most of it has to do with I want to have a lot of variations of these questions. So it would be a very individualized experience, and yet all the variations are about the same in terms of difficulty. And a proof question like this has no variation whatsoever, because if a proof works, it's the same proof, right? Everybody can use the same proof when it is just a proof question. So I'm not going to have proof questions for this particular final. All right. So I'm not seeing any additional questions down here. So what I'll do is I'm going to stop the live stream. I will keep an eye on the text channel whenever I can, but I do have a few things to do in the afternoon. I have a curriculums thing to do at 3, a uni meeting at 4, and I have to kind of review some documents prior to both of those events. So I would keep an eye on the text channel, but I cannot promise that I can respond in a timely manner in this case. Yes, I will still have office hours. So right now is 1:30. So between 1:30 to 2:30, I'll be, at the computer. So if you guys have questions, I can try my best to answer those questions. But I cannot promise anything after 2:30. All right, so um well, so as far as I'm concerned, I'm gonna have to drop off, but I can answer questions when people ask me specific questions, but I cannot work on live streaming, and reviewing questions until I got stuff taken care of, and it will be at least to 5:30 when the last meeting ends. And I think there's something happening at 6 o'clock. I cannot remember exactly what it is. I just remember there are lots of stuff scheduled for the rest of the day. Um, yeah, last day of instruction, and I got some stuff piled on, and it's not just me either. A lot of these meetings, the union has a lot of stuff to do, because there will be some cuts in terms of classes, and the union is involved in trying to help to determine what classes to cut, and we want to minimize the impact to students, and we also want to minimize the impact to part-time faculty, because part-time faculty are the first ones who lose teaching assignments. So to answer James' questions, there will be prologue, but they're not as questions in the final. They will be more or less in the format of an assignment where you have some time to work on it, and it will be due on next Wednesday. Now, when I can have the questions ready, that's it's kind of like a separate question. But we kind of talked about that. Yep. Yeah, so Carol is correct. It is heavy stuff. We would like to save everyone, but at the end of the day, there's not enough funding to do that. The college as a whole is seeing a overall budget reduction of 11%. So that's a lot. Okay, it doesn't sound like a lot, but it really is a lot of money. So so there'll be some cuts in terms of FTE, full-time equivalents, which means some departments won't be able to offer as many classes as they did this semester.
Have you felt like, in your opinion, noticed or heard around it all that do you feel like students use the services less when it's all online? Because like I'm a tutor at Mesa, and
hmm
like for the last like 3 weeks, I've worked like 3 hour shifts without seeing like a single person.
that's a very good question, Nick. So I can. Oh, okay. So Brenda asks, says, can I? Yes. So I will update you guys as much as I can as I start to crystallize what type of questions I'll be asking. Very likely, it is going to be a graph that I will present to you, possibly with certain pieces missing, and I need the algorithms to run in a certain way, and you have to fill in the blanks, in order for the algorithm to work in that particular way. So I think that's probably um, the general idea of how the final exam is going to look like. But the exact detail, I still cannot determine yet at this point. But it's going to be based on the algorithm. So it would definitely help to fully understand the two algorithms and understand exactly how they work. All right. And Alex is typing. The final exam is on Monday. Yes, we kind of talked about it today during the lecture, and I think the exact time is 12:45 p.m. to 2:45 p.m. on Monday.
Yep.
Yeah, Pacific Daylight Saving Time, to be more exact. Okay, so getting back to next question. Okay, so the answer is really kind of interesting. It's not uniform. Okay, it's not uniformly more or less.
Mm.
Um, I find that I interact with students more often. Once we go fully online. So before, I guess some people would kind of hesitate or do not have time to visit me during office hour. But once
Okay.
I move everything online, I keep an eye on Discord, and I do that a lot. I mean, I use the computer a lot, for the entire day. So when I see a question, either by direct message or by class specific text message, I just go ahead and answer those questions. Most of those are fairly easy to answer, not a big deal. So I find that I interact with students more, with more time. When classes go 100% remotely, but I also know that instead of going to a classroom with like in this class, typically our class would still have like about 40 people. But when you look at the number of people who are participating in Discord in the live stream, we are looking at the most one half of that number. So
Yeah, I
where's
noticed.
where's the other half? So where's
Are
the
they in
other
the
half?
class?
Um, there are not too many people who drop the class, so the class still has at least 40 people, on roster. But
What?
when we look at Discord, now I know we are way off class time right now, so now it's not a very representative number. But even
Yeah.
during the lecture, we are only seeing about no more than 20 people. So where's the other half of the class? I have no idea where the
How
other
many
half is. Hmm?
how many tests did you get?
How many what?
How many exams were turned in?
Um, that is a good question. I cannot remember how many were blank.
Okay, that's interesting.
Yeah, so there are some people who are officially still enrolled in the class that did not drop, but they did not even participate in exam two. We are not
Uh,
talking about people who just did not have enough time to finish every single question. There are quite a few people who ran out of time. It's not a big deal. Okay.
yeah,
um, but we are talking about people who did not even try. They did not even sign in to do anything with their question. So I'm looking
yeah.
at the roster right now. We have 41. We still have a roster of 41, and so I have no idea what was happening to basically one half of the class. Are they watching the YouTube recording or what? I mean, I do not know.
That's fascinating. Like just how drastically and how fast things have to change, on like the turn of a dime.
I think I think because of the lack of the structure. So even though I try as my best. No, Brandon, I think more than people took exam two, but I can safely say that there are probably about 10 people who did not participate at all. Um, but those 10 people are still in class. They're still on roster because roster says I got 41 people, but I can tell you there are at least 10 of those question sheets that came back completely blank. Okay, nobody attempted to change anything on those documents, so that's kind of strange. But getting back to Nick's point is, I think it skewed, it changed the participation proportion, okay, for the lack of a better term.
Yeah,
Yeah, I think people who really want to get something out of a class, people who still want to achieve, those people would kind of utilize whatever resource is available. So in this class we have Discord, in other classes maybe Zoom and some other online resources, and at a certain level it is more flexible because now you guys can just kind of get into Discord and ping me. Okay, if I'm online, people can just kind of ask me questions and I will be able to answer those questions. So I'm
yeah,
actually more available than normally because normally I'm running around the whole day and I don't even stay in the office or in front of a computer for that long, but now I do. But at the same time, because of the lack of structure, people do not have to go to class, there's no roll taking and whatnot.
yeah.
Okay, some people just kind of, I guess,
Some of it
for
need
the
that.
lack, exactly, for lack of a better term, they probably forget that they're taking certain classes. I think that's actually what
Yeah,
is happening is some people did not even remember that they were taking a particular class, or they have missed so many classes that they go like, I'm not even gonna bother.
yeah.
So,
I was nervous even, like because I'm one of those people that doesn't really like to read. I'm real lecture oriented.
hmm.
Like so, I could see how like a lot of
Oh, you're dropping out, Nick.
I could see how a lot of people would be thrown off and feel slightly like uh not as comfortable.
Yeah, I think it's kind of interesting because it doesn't take much to participate in the live stream. Okay, people can just kind of sign in, listen in, and not type and not talk. Not text. Not do anything, right?
Hmm.
And half the class is not even doing that. They're not even just going like, okay, I'm just signing in, I'm just listening, and I'm not raising my hand, I'm not talking in any way, I'm not. But they're not even doing that. So that is kind of strange to me.
Interesting.
Yep.
We'll see how it plays out next semester.
Yeah, so but imagine if this is happening to a class like this in CISP 440, which is capstone, this is one of the last classes that most people take before they graduate and transfer somewhere else.
Hmm.
So if it's happening to this class, imagine what would happen to a ESL class or a GE class, okay?
Oh, I know. Yeah,
Right? Because in
yeah,
those classes, one first of all, they're not going to be as tech savvy as a average student in this class, because you
yeah,
guys have to get through what 430, 400, 360, and so on. So you guys
yeah,
have to be proficient with using a computer to a certain degree to get here. But with an ESL class, there's no such thing. Okay, everything
hmm,
used to be just completely face to face. Everything is paper based, and now suddenly over a week, boom, everything is online. So
Yeah.
I can only kind of imagine the drop off of participation in those classes.
Yeah, absolutely.
Yep.
Yeah, I get that.
All right. Okay. So I'm gonna stop. Oh, okay. Brenda is typing. I'm just gonna wait a little bit. Just to clarify what modules will be on the final exam. So I would say counting. Okay, since we are still streaming, I can go back to the modules. All right, so, but I have to go pick the correct one over here. All right, I think this is the right one. Yep, it's 440. So we are going to have one quote unquote exam assessment activity that involves prologue programming, but it's not going to be within the 2 hours of the final exam. I will give you the question as soon as I can, okay? But then you have until next Wednesday to turn in your answer. So to you, it would look like quote unquote a homework assignment from Canvas perspective. So that's for practically calculus and prologue. The final exam will have quite a bit of question related to graphs. So we are going to have both Dijkstra's algorithm and also A-star algorithm. There won't be any questions related to big O, omega, and theta. Okay, so these topics will not be on the final exam. And because we did not include counting and the probability stuff in the second exam, so they will be in the final exam. So there will be some questions related to counting, um, some questions related to combinations, permutations, um, and the binomial distribution, and also nope, that's probably it. Okay, um, so I might put up some additional recording to kind of remind people what those topics are. I mean they're all recorded already, um, but in terms of what type of question I can ask about discrete probability, I will give you guys some samples as soon as I determine what kind of question I'll be asking. So time is tight because I have to have all the questions ready by Monday, but I still want you guys to have a kind of something to practice on. So I have to kind of work on this really fast to get those things out. But today is really busy for me, so I don't think I can crank out anything by tonight. Krishna is asking, are there examples of those types of questions? The answer is yes. If you look at exam 2, some of these sample exams have questions for probability and also for all of these topics here. I can give you guys some extra one too. So let me add this one here. Yeah, so this is from exam 2 from last year. Okay. And I think it includes questions regarding probabilities and counting. So I'm going to pin the message first. There we go. And then open it on the side. All right, so I'm just looking at it really quickly here. It has got yeah, so that one, okay, so let me just pull it up here. There we go. And fit the window in like that. There we go. So if you look at the question that I just pinned from it's exam 2 from last year, you can ignore question number 1 because question number 1 we cover already in our own second exam, so we don't have to worry about that. And then the second question is related to counting. In a dungeon room, a player is to choose 5 different potions out of 54, blah, 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 blah. So you can, yep, definitely. So Brand is asking, so all our exams and homework will be graded after the final? Yes, they will all be graded for sure. So this is a question related to counting and probability. Question number 3 is, you don't have to worry about this one because we got it already in exam 2. Question number 4, we got it in exam. No, we do not. Proof questions are very difficult to ask when I want individualized questions. So I'm not going to ask this kind of question. So question number 5 is related again because question number 5 is about probability. So question 2 and 5 from the second exam from last year are the ones that you want to take a look at in terms of understanding from last year's perspective what kind of question I asked about probabilities. And I still have to kind of think about how to individualize those questions for this year because they don't really lend themselves to individualization. So so I have to kind of think about how to make it so that it is individualized. There we go. So is it possible? I will try, okay, because I have to refine, I keep refining, changing the way I want to assign the points. But this time it's really helpful that I actually corrected every single uh, submission first before I try to come up with a number for each kind of question. So that actually helps a lot, at least from my perspective, because a lot of times I would make a grading scheme and then later on find out that this doesn't seem to work the way I think it would work. Then I have to go back and change it. So, and Alexander is typing. All right. Oh, okay, no problem. No problem. All right. But at least, based on today's discussion, I think some people can kind of self-assess, their own answers in the second exam and have a general idea of, where the grade is going to be because, I corrected every single one. So you guys got feedback from me already. By accidenti. Okay. Yeah, they are already corrected. Well, if you look at the shared document, they have my. Oh, right, right. The feedback does not show. Oh, right. Now I remember because somebody told me about that. Okay. I still have not addressed that. um, I actually put in corrections already, but because you were only shared as a viewer, the correction that I put in, which are marked as suggested changes, did not was not visible to you. So I have to come up with a way so that that becomes visible. Oh, right. So there's that technical issue that I have to deal with. Okay. All right. So let me work on that one, because I cannot show you an example because if I show you an example, that means I'll be showing you somebody's. Oh, wait. I have a way to do it. Because at least I can show you what I have that you cannot see. Not that it's going to be helpful, right? But at least you can kind of understand what it is. Okay. So let's just say that this is somebody's submission. Nobody gets question number, I mean variation 46. So don't worry. Okay. So what I did was I turned on the suggestion here, in a Google document. So I would go to a particular answer and click on something, and I will say, okay. So I would type my comment like that, and it would be highlighted. Okay. And I did not know that when I do something like this, when I put in suggesting changes, that it is invisible to you guys as viewers of the same document. So that's an issue that I have to deal with. Is somehow I have to write a batch program in Google Script to make this visible to you guys. So that's something that I have to do because I marked every single one already. It's just that you cannot see it, unfortunately. Okay, so that's something for me to do as well. So I got a good pile of stuff that I need to do. All right. So any other questions before I sign off? Nope. Okay. So I'm gonna sign off now because I got a whole big pile of stuff that I need to do. Hopefully I don't forget to do some of these.